Hi, I'm Brandon Christopher King, and in this series, we're exploring a groundbreaking new way of looking at motion using my RLFlow model of reality. You've probably heard of Isaac Newton. His laws of motion have shaped how we understand the universe for centuries. But what if I told you we've been looking at them all wrong? Newton's laws have worked for everything from engineering bridges to understanding the orbits of planets. But what if motion isn't about solid masses at all? What if it's all just flow? Not particles being flung around, but a universe where everything moves because it's caught in a vast, interconnected current. Welcome to RLFlow, a new way of seeing motion, where Newton's laws aren't just about objects, but about the very fabric of reality itself. Isaac Newton gave us the laws that built the modern world. From the motion of planets to the engineering of bridges, his principles have stood the test of time. But what if I told you we've been looking at them all wrong? Newton saw objects being pushed and pulled by forces, but what if motion isn't about solid masses at all? What if it's all just flow? Not particles being flung around, not forces acting across empty space, but a universe where everything moves because it's caught in a massive, interconnected current? Welcome to RLFlow, a new way of seeing motion, where Newton's laws aren't just about objects, but about the very fabric of reality itself. Newton's laws have served us well. They explain how cars accelerate, why baseballs fly, and even how planets orbit the sun. But there's a problem. His laws treat mass and force as fundamental, but never tell us why they exist in the first place. Why does mass resist motion? Why does force act at a distance? RLFlow answers these questions. It reimagines Newton's laws by removing mass and force as primary concepts and replacing them with flows. Instead of objects being shoved around by invisible forces, everything, motion, resistance, acceleration, emerges from interactions within a vast, cosmic flow field. This isn't just about mechanics. This is about rewriting the foundation of how we see reality. Newton's first law says an object at rest stays at rest, and an object in motion stays in motion unless acted on by an external force. Simple, right? But let's rethink this. Imagine a river. A slow-moving current keeps flowing, unchanged. A whirlpool keeps spinning, stable. In RLFlow, inertia isn't about objects resisting motion. It's about the natural stability of flows. A flow stays steady unless something disturbs it. Take a look at my equation. This equation represents flow inertia in RLFlow. Here, motion isn't a separate thing. It's just the persistence of a stable flow pattern. If nothing interferes, it remains as it is. That's inertia, not as some mysterious resistance to change, but as a fundamental property of a stable flow. Think about this. The Earth doesn't just keep orbiting because of inertia the way Newton described it. It keeps orbiting because the solar system's flows remain stable, like a whirlpool in a cosmic river. Stability is motion. Motion is flow. Newton's second law, the famous F equals ma, tells us force equals mass times acceleration. It works, but only if you believe mass is some intrinsic property of objects. But what if mass isn't a thing at all? What if it's just flow density? Think of a whirlpool in a river again. The denser and more stable it is, the harder it is to change. It's not because the whirlpool has mass. It's because it's locked into the flow. Now, look at my equation for this. In RLFlow, force isn't a push or a pull. It's just the effect of two flows interacting. Acceleration isn't about an object changing speed. It's about a flow adapting to a stronger current. The more stable the flow, the harder it is to change. Just like the more massive an object is, the harder it is to accelerate. So when you push something, you're not applying force to a solid object. You're introducing a new flow into the system. And just like two merging rivers, the stronger one changes the motion of the weaker one. Newton's third law says, for every action, there is an equal and opposite reaction. It's why rockets propel forward when gas shoots backward, why a gun kicks when it fires a bullet. But in RLFlow, this isn't about separate forces. It's about the reciprocal nature of flows. Ever step into a river and feel the water push against you as you push against it? That's RLFlow's third law. There is no separate reaction. There's just flows balancing themselves. Now, we have an equation to represent this as well. In RLFlow, when two flows meet, they naturally adjust. There's no need to apply a force and expect a reaction. Instead, the flows simply find a new equilibrium. That's what's happening when you push off the ground and move forward. It's not an object reacting. It's the flows adjusting around you. Newton's laws work great for everyday mechanics, but they struggle at extremes. They break down in black holes. They can't explain quantum weirdness. They don't connect with relativity, but RLFlow can. By replacing mass with flow density, force with flow interaction, and reaction with reciprocal flow adjustments, we suddenly have a framework that works at all scales. It explains why galaxies spin without falling apart. It connects the macroscopic and the microscopic. It makes force, motion, and energy a part of the same seamless flow. And it leaves us with a profound realization. The universe isn't a clockwork machine. It's a river, one that stretches across time and space, shaping everything we see. So let me ask you, what happens when we stop seeing objects and start seeing flows? What happens when we stop thinking in straight-line equations and start thinking in dynamic, ever-evolving patterns? We don't just get a better model of physics, we get a completely new way of seeing the universe. Newton saw the world as objects moving through space. RLFlow sees the world as motion itself, endlessly unfolding. And once you start seeing the universe this way, you'll never see it the same again.